All right, here is another exercise. So we have two strings s and t. We want to return true if and only if t is an anagram of s. And so one way that we can go about doing this is, well, basically to be an anagram, that just means that you just take the string and rearrange the letters. So if you're to put the letters in order for each of the words, then the results would be the same. And Python has a built-in function for ordering things. So what we could do as a very simple solution is we could return sorted s equals sorted t. And once again, I'm writing this because I like to write. But yeah, this is a solution. This will work. But that's kind of boring, so we're going to ignore that. And we're going to think of another way. And basically, this other solution, we could just say, another thing that you could do is you could try using dictionaries. So you could say, okay, so let's, if you were to take each string and make a dictionary where the keys are the unique characters and the values are the number of occurrences of each character, then those two dictionaries would have to be the same. So you could do that. You could make a dictionary for both s and t, fitting that description, and then check if those two dictionaries are equal. But we're actually going to do a similar approach, but kind of take a shortcut, because instead of trying to build s and then build all of t and then compare the two final dictionaries, what you can do is you could build s and then you can start taking things away from s, or using t to take things away from s. And if there's anything that you're not able to take away, then there's some discrepancy, which means that the two dictionaries are not the same. Okay, so let me show you how this will actually work. The first thing that we're going to do, and this will get us like a shortcut, and this will make some of the later coding easier, is we can do if the length of s is not equal to the length of t, then it cannot possibly be an anagram. So then we'll just return false. It's a straightforward scenario. Okay, so otherwise we have to make the dictionary. So I'm just going to call this dictionary counts, instantiate it, and then we want to add everything from s into counts. So for each character in s, we want to so here's what we need to do. It's possible that this character is not yet in the dictionary, and if the character is not yet in the dictionary, then we want to add it into the dictionary and add 1 to the value so that the value is 1. If it is in the dictionary, then we want to get the value from the dictionary and then add 1 to it. And so this line of code does all of that in one. It basically it creates the character in the dictionary if needed. But if the character is already there, then it just increases the count by 1, which is what we want. Okay. So that's it. And once we loop through all the characters in S, that gives us our dictionary. So then we have to start looping through the characters in T. And so so we added the characters in S. Now we're going to remove the characters from T. So if the character is in counts. So if this character is not in counts, then that must mean that there is some character in T which is not in S. And so then the dictionaries are automatically not the same, which means it can't be an anagram. So, later on we're going to put else return false. Okay. So if the character is in counts, then we want to take counts character, which we know is not going to throw an error because it's in counts. And we're going to subtract 1 from it. All right. And now we have to check if we run into an issue here. So let's see here. If counts character, if the counts is less than 0, then that means that this particular character occurs more times in T than in S. And so then we want to return false. Then, let's see here. So if all this, else. So if the character is in counts and we do this, else return false. And then at the end of this, we return true. Basically, we return true if we didn't run into any issues. Now let's take a moment to think about this. So return true if we didn't run into any issues. So is that true? Is that correct? So like basically if you go through all of this and haven't returned false, are you automatically going to return true? So let's think about this. So if we've gone through this entire, if we've made it all the way through this entire loop, then we've looped through all the characters in T, and every time the character was still in the dictionary and we're able to subtract 1 without going below 0. And the key fact here, like your gut reaction, at least my gut reaction at first when thinking about this was, okay, so we haven't run into any scenarios where the counts has dropped below 0, but does that guarantee that after this, at the end of this process, does that guarantee that counts character equals 0 for every character in the dictionary? And the answer is yes, because way back up here, we confirmed that the lengths of S and T are the same. Because if they weren't the same, we would have returned false. Okay, and so since the lengths are the same, it's sort of like a pigeonhole principle argument. If we were able to remove every character from T, if we're able to return every character in T from counts, then that means that every character in T appeared in counts. And also the number of occurrences in T must have equaled the number of occurrences in counts. Because if it was more, then we would have ran into this issue and we would have returned false. But if it were less, what would happen if it were less? Character were in counts. Well, that couldn't be the case because if this character occurred fewer times in T than in S, then there would need to be some other character in T that occurred more times than in S, because that's the only way for the sizes of the strings to be equal. Or else there must have been some character that was not in S in the first place, which would have returned this other condition. So if we get through this entire thing and we don't run into any issues, then we return true, because that means that the dictionary must have been the same. By the way, another way that you could do this is instead of returning false if the counts drops to 0, another way you could do this is you could check if the counts of the character is equal to 0, then you could just delete counts character. You could just delete it from the dictionary. And so then instead of, and so then when you would go back, if that character were to appear again, then instead of moving on to here and dropping the counts below 0, you would just automatically go down to the else clause and return false, because in that case it's been deleted, and so it would not be in counts anymore. But that's just an alternate way of doing it. Both solutions will be fine. All right, so let's actually code this up and make sure that this works. Okay, so the first solution is return sorted S equals sorted T. And it works. Yeah, it's very, very simple. All right, so let's do our other solution. So if the length of S is not equal to the length of T, then we return false. Counts is a dictionary for each character in S. We are going to set counts, the character. We're going to instantiate it if necessary, or else add 1. Now let's loop through T. If the character is still in counts, then we remove one instance of it. And then if we have dropped below 0, then we return false, because in this case that character occurs more times in T than in S. Okay. So going back here, if the character is not in counts, then we also return false. And if we've made it all the way through the process and not run into any issues, we return true. Let's put another space there just to differentiate these. Okay. And let's go ahead and submit it. Let's make that fully visible. So yeah, so there we have 2 ways of doing this problem. One that's sort of like a very short solution, and one that's super quick. So there you go.